Heino Falcke is a professor of astrophysics at Radboud University. He's been here since the early 2000s, and he's been slowly growing a group of black hole scientists. Heino is also a part-time preacher. He preaches at his local church in Frechen in Germany. Heino really enjoys his duality between religion and science. He thinks that this is a part that really kind of enhances his views and his thoughts as a scientist, both have his religious and his kind of more logical scientist side.
My grandmother grew up in East Prussia in a very remote area on a farm, and she was always looking at the night sky, and she wanted to be an astronomer, but she couldn't. So I think she inspired me a little bit to look up into the stars. And she took me to an observatory in the middle of Cologne to look at Saturn. And you could see with your eye through a telescope Saturn somewhere, you know, this little bit of light that you usually see, now you see in a ring and a real planet. This was just fascinating. When I was a teenager, I was making little experiments. I would make my own black powder secretly so my parents wouldn't know, as to build little rockets to go up to space. I come from a family with a religious background. We've been in a Protestant family for several hundred years in the same church, in the same village. And the questions, the religious questions and God was always present somehow. But it was remote and distant. And I wanted to know more about this. What are people thinking? What are they believing? So I would not accept simply what my parents would say or my grandparents would say. I was just curious. I think the same curiosity I had about science later, I also had about religion, to find out what is it that they're talking about. If you look at the history of science, then you will see that's part of the big quest of humankind to actually explore and understand the world. And the religious questions and philosophical questions and scientific questions were all part of the same thing. We separated these things now. But I think they belong together because we're still humans. Of course, the religious questions often about a different level, about people, about our purpose. And these are questions that physics can never answer. And the Bible is full of stories, of experiences of people from which you can learn. And I think it never hurts to learn from people, also of other generations.
So when Heino gives talks, obviously it's his kind of preacher side that comes out. He starts to preach a little bit, like giving a story. He references a lot, God and the heavens when he talks about astronomy, which I really enjoy because I feel like his duality between astronomy and religion connects with people very easily.
Heino also puts a lot of trust on you, which is on one side it's of course pressure to actually deliver, but also it's nice that he shows you the trust that he believes that you can do it. And he will not be bothering you every week to see how your progress was, because he knows that you will come to him if you have a question. I think he picked us for a reason, to have people that are independent and have social interactions, and also that they nicely connect to each other. So he built a really nice team around him that could already work together from the beginning.
In science, it's not enough to just have an idea. You have to convince yourself that the idea actually carries through and can be realized. And then you have to convince others. And you don't want to convince others by just telling them. You want them to find out themselves. I think that's how it works in science. And that's why it takes so long, because people have to discover for themselves that it actually is possible.
So when I started my PhD, Heino actually challenged me to make a virtual reality simulation of a black hole. And the deal that we in the end made is that I got a very expensive desktop with a great graphics card in it and everything you need to create such a black hole in virtual reality, plus the virtual reality goggles itself, of course. And then he really challenged me to do this within a year.
In physics, we limit ourselves to things that we can measure with machines, to to matter, to things, to mathematics. But of course, life is often much more complicated than this. Humans are much more complicated than this. And so we tend to forget that humans are different from the world that we live in as physicists. And so it's important to be taken out of that world, that bubble that we live in as physicists, and to understand the richness of life in the world and all the questions that people have, which are not just only about physics.
After a 2-year process of analysis, we finally sat in the press conference room at the European Commission in Brussels in 2019. And there I sat in the front row and I saw Heino get up, and this movie started to play behind him. And he started to explain in front of loads of journalists on April 10th, 2019, about our observations, and saying that there is a black hole in this galaxy 55 million light years away. That moment I will never forget. And it started lots of scientific interest in our results, but also amazing public interest. And then the next day we saw the black hole image on the front page of newspapers all around the world. And it was truly shocking to see the response of the public. For someone like Heino, who has been working on this project for about 20 years, it was really an important moment for him. He always says, although this image is blurry, it's the most beautiful thing he's ever seen.
Yeah, the first picture of a black hole is almost an end point in a long quest to actually really understand black holes, to find black holes. But it's also actually a new beginning, because now we're actually going from the question of, are there black holes? We're now asking, what kind of black holes are? Can we measure them? What can we measure at the edge of space and time? And so I think we're entering a new phase now, where something that was like a mythical object, like black holes, which was theoretical objects, are now something part of measurable science. The event horizon is within reach. We'll never get there exactly, but we're getting as close as possible. And we can study it, we can measure it for the first time with different methods. The last century was a century of particle physics. This century, I think, will be the century of space-time physics. Something that started in the minds of people like Albert Einstein is now become observationally experimental science. I'd really like to see what's inside a black hole, to know what it means to actually travel in time, because that's in principle possible there. But of course, if I'd find out, I'd never be able to tell anybody. So what's the point of, of doing science and making discovery, not being able to tell anybody? And of course, you can never know everything. And maybe when at some point I'll be dead, I will have not answered all my questions, and maybe I ask God Almighty, what are the things you didn't let me see? What does it look like inside a black hole? So maybe I get to see it eventually, who knows?